Do you need someone to do your programming assignments? Do you urgently need programming assignment help? Do you need an online coding help or feedback? All of these problems have the same solution, and Programming Homework Help is the best website to do your programming assignments. We come with multiple experts with many years of experience. We provide high-quality assignments. We deliver your assignments in a very short time, even urgent programming assignments, and we come with multiple customer reviews in our website. You can find more about us in our website, programminghomeworkhelp.com. My name is Elena and I am a tutor at Programming Homework Help. To demonstrate the high quality of our programming work, in this occasion I will show you the implementation of DES encryption and decryption using plain Python. This program will implement DES cryptography using Python. This allows the user to read a string and encrypt or decrypt it using a random key of 56-bit. We start importing the libraries we need. In this case, it's only random library that we will need to generate our random numbers. I'm gonna start giving a general overview explaining the main function, then explaining the other functions involved in the process. We start initializing the random seed, then we print the messages for the start of the program and asking the user to enter the text to encrypt. As long as the user does not write exit, we can continue to a loop in which we use a function to generate a random key of 56 bits. Then we use this key to encrypt our text, and we print our encrypted text and decrypted text and a key. Then the program asks the user for another text to encrypt until we decide to finish by writing exit. Now that we know how the main program works, let's see how each of these involved functions work. Let's start with the encrypt function that will encrypt the given plain text using DES with a given key, returning the ciphertext. We start defining this variable, number of blocks, that will round up the length to 8 bytes per block, and we initialize the empty string in which we will save our ciphertext. Then we start a for cycle in which we will initialize the 6-bit value on 0, and we will define the current block position in the text. In another for cycle, we will use value to make a space for another character. If the position is not padding, that means the length of the text we introduced is bigger than the current position, we will append the ASCII value that we obtained with OR. Then we proceed to apply our DES function to this block. Here we initialize to an empty new string, and we will start a new for cycle in which we will start getting the lowest 8 bits as our character and append it to the left to the current ciphertext. Then shift right to get the next character. At the end, this block's ciphertext will be added to the global ciphertext. Finally, we will return the ciphertext string. The next function is decrypt, in which we will decrypt the given ciphertext with the given key, returning the plain text. We have almost the same structure than the encrypt function, but here we are just switching the positions of the ciphertext and the plain text. This way we will return the plain text string. Now we have the permutate function in which we will permutate the number bits using a given permutation table. Here we initialize our result with a 0 value, then we open a for that will get a bit from the required position and will append this bit to a result variable. Then we have these two simple functions that will either rotate the given number one bit to the left or one bit to the right, using only key and bits variables. Next, we have a substitution box function that will be applied to a number. This one is also very short. It only will imply to get the row number and, based on this number, obtain a column for the inner 4 bits. This will return a function with rows and columns. This DES function was mentioned earlier, and it executes a single pass of the DES algorithm using the given 56-bit key. Here we have defined our permutation tables we talked about earlier. We have the first permutation, expansion function, last permutation, PC2 permutation, intermediate permutation, and SBox1 permutation. Then this number variable realizes a permutation on the first block, defining that the left is 32-bit upper of this number, while the right one is 32-bit lower. Then, depending if we are or not decrypting, we can start inverting the shifted key, rotating it to the left. If not, we can just proceed to run the function interactions. We start a fourth cycle that will start rotating the key number by 1 bit, and using the PC2, expansion, and round key permutations. Then we initialize the SBox number to 0 and proceed to the next 4 cycle that will get a chunk of 6 bits from the number. Here we use this substitution box function defined above. Then we append this result to our total SBox result. When we finish the cycle, we proceed to apply the intermediate permutation and establish our new right and new left for the next round. Next, we need to build our 64-bit number again using our new left and right with a swap. Finally, we do the last permutation with our now 64-bit number, then we return this obtained value. The last function to explain is the printable string function that will return a printable string in which we will replace the non-printable characters by dots. We do this initializing our printable string, then proceeding to this fourth cycle that will print each character that is in the range of the ASCII code between 32 and 127. If this character is not inside this range, we will print a dot. And here we finished the implementation of DES encryption and decryption using plain Python. You can trust that our programming homework help is legit. In our website, you can find the reviews from many people who have hired our programming homework help services. We hope this video was useful for you. For any assistance, you can visit our website programminghomeworkhelp.com or send an email to info@programminghomeworkhelp.com. Thanks for watching.